We're trying to build a new large flood alleviation reservoir for the Environment Agency called the River Roading Project, designed to protect properties downstream in Essex. Because it's a flood alleviation reservoir, we've got a very high compaction target of 95% maximum dry density. We're achieving that at the moment through 9 passes with the role you can see behind me. We're trialling at the moment using new technology to try and calculate when we've hit that target. If that target's hit at a lower number of passes, let's say 7 instead of 9, we're reducing, or we're trying to prove that lower number of passes hits our target compaction requirement and therefore saves carbon.
So today we're with our BW216DH roller installed with Terrameter. Terrameter is a system that measures the ground compaction underneath the drum. So the way that Terrameter works is we use a stiffness value target. So by completing some density testing over a number of passes, we can then see what our physical stiffness value is in the roller, and that is the target value we can work to. So potentially we're looking to reduce the number of initial passes that we are trying to achieve, which in turn is going to save us fuel and emissions and wear on the machine as well. We've seen a number of trials across the UK with this system, and we know that this is working in terms of reducing the number of passes that people are doing. But it is becoming more and more popular. Really, HS2 has pushed the boundaries with this, but we're seeing it on a lot of other projects now. So Terrameter obviously gives the stiffness value, but then we've got the BOMAP GPS system, which is recording all of the data.
Okay, so on screen here, we've got, so this is my login to the BOMAP system. So the various colours you can see here show the number of passes that the roller has achieved at various areas of the new clay embankment that it's compacting. So the blue colours indicate more passes, the red colours where we haven't maybe achieved the number of passes we should have as yet. So this is all live data sort of streamed straight back from the roller itself from site, despite it being probably half a kilometre away from here. And the operator who's in the roller themselves have a tablet inside the cab who has access to all this data at the same time. So they can then see where they may have achieved compaction or not achieved compaction. So this information is really important for us here on site. It helps us with efficiencies, how much fuel we use, costs, and also program efficiencies as well.
In terms of how this could be scaled to other projects, there's generally 2 ways of specifying earthworks. You've got performance specifications and earthwork specifications. Or method specifications. Method would specify the roller type and number of passes. Performance would generally be around the maximum density you need to achieve. If this sort of equipment works well, it could be shifting more projects towards that performance spec as a target rather than the method specification.
This trial is running on an embankment construction. So this embankment that we're standing on right now is part of a flood defence scheme. This is a really common asset type across the Environment Agency, so it's got fantastic potential to be scaled on future projects. We've deliberately targeted embankment construction, knowing that there's going to be lots of schemes like this in future doing very similar types of compaction. So we can get the results for this to show that there's a chance to save some carbon and minimise over compaction. We could be onto a really good to deploy technology for the programme.